Greetings to the viewers of this video. Today, we are going to see about surface tension. From the name, we could say that it is a tension on the surface of liquid. Surface tension can only be observed in liquids. Now, let us understand it clearly by taking water as an example. Consider a glass full of water. If I am keeping an object with a small mass carefully on the surface, it will stay still. It is actually not floating, but held on the surface by the tension of water. This is because the tension on the surface of the water is strong enough to hold it until any external force acts on the object. What is the reason behind water holding this small mass? Why does the surface of water holds the object? Then, what about the bulk of fluid? Is it possible to measure the metabolizing capacity of liver by measuring surface tension? Let us solve these questions. We know that water has intermolecular hydrogen bonding in it. Each water molecule is interconnected with each other by hydrogen bonding. This force of attraction between the like molecules is called as cohesive force. The water molecules at the bulk gets pulled by all other molecules due to hydrogen bonding. This prevents the grouping of water molecule in the bulk. But at the surface of the water, there are no water molecules above the surface, only air is present, so they are set free. This helps the water on the surface to group, form strong bonds, and a tension is created, which is not present in the bulk of the water. These tighter bonds support a particular level of pressure, and responsible for the elastic nature of water. Now, consider the surface of the water, and we can take a part of fluid and mark it like this. If we see the force acting on this part, there will be forces acting on both sides in the same magnitude, one on left, and another on right, so there will be no net force, and no movement of fluid. Let us take the force acting on single side, F, and the length of the fluid as L. Then the force F, acting on the liquid segment of length L, will be proportional to each other. The force is directly proportional to the length. To remove the proportionality, we can introduce the letter S. This S, surface tension, is constant for a particular fluid, at particular temperature and pressure. Now, the equation becomes S is equal to F, force, divided by L, length. This is the equation for surface tension and the unit is Newton per meter. The surface tension is responsible for formation of spherical globules in the emulsion, and sphere shape of falling water drop. Have you ever thought of why the raindrops are spherical in shape? It is due to surface tension. Because the spherical shape is having the least possible surface area, so it can resist any of the external forces in the atmosphere. This is the reason behind why the bubbles are also in spherical shape. There is also a clinical application of surface tension, that is finding the metabolizing capacity of liver. By measuring the surface tension of urine, the surface tension of urine will be lowered if bile is excreted in urine. If bile is excreted in urine, it shows that liver is under not good condition. Hope you understood this topic clearly. See you on the next video. Thanks for watching.